Welcome back. We're going to continue our discussion on electronic configuration. Now, if you understood how the electronic configuration of elements in domain 1 or domain 2 works, then writing electronic configuration for a cation and anion is no means difficult, because all you're doing is removing or adding electrons. Now, if you remember from one of the earlier videos, I've mentioned the tip. Cation means positively charged. That means electrons are lost. And how do we know how many is lost? Is if it is +1, you lose 1 electron. If it's +2, you lose 2 electrons. And determine how many electron count you should have is very important. Okay. So for instance, if you're dealing with magnesium 2+, which could be written, say I give you this. Okay. You must know how many electrons you're actually working with. So when you finish writing the correct configuration, you can do the electron count to make sure the counts match to how much you should have. Now, magnesium's atomic number is 12. So +2 means you've lost 2 electrons. So 12 minus 2 is you're only working with 10 electrons. Okay. Now let's follow the rules and try to work with these two elements. Okay, this is from domain 1, this is from domain 2. So first you write the sequence, okay, 2s, 2p, and 3s, right? That's where magnesium is found. Now go ahead and start filling 2, 2, 6, and 2. Right? I mean, imagine I stopped here and I know I had 10 and 12. Now this is not the electronic configuration. This is for magnesium. What we want is magnesium 2+. They're not the same thing, right? Now, how many we can lose? We can lose 2, right? If you follow, this is the only other additional information you need is you're removing electron or electrons from the furthest most orbital on the right, and that would be this. And so we are losing 2 electrons, so we write everything the same, right? Now we have only lose 2. We're only removing this 2 electrons. So we just don't write the orbital. Now if there is any electrons left, even after you remove, then you write the orbital and write how much there is left. But in this case, we have to lose 2, right? So when you lose the 2 on the further one, that orbital is now empty. So you cannot write an empty orbital. So that is the electronic configuration of magnesium, which is 1s2, 2s2, and 2p6. Now chromium, again, you got to write the perfect electronic configuration and then remove. Okay, you got to do all the shuffling, everything. This is an element in domain 2. So 1s, 2s, 2p, 3s, 3p, right? 4s, and 3d, right? And then we fill. This is the first step. Then we fill. So it's 2, 2, 6, 2, 6, 2, and whatever's left. So it's 10, 12, 18, 20, and chromium is 24, right? So that means we have 4. Now we shuffle. So 1s2, 2s2, 2p6, 3s2. The 3's comes with the 3, the 4 comes with the 4. So 3s2, 3p6, 3d4, 4s2. This is the correct electronic configuration for chromium, not for chromium 3+. Chromium 3+ means we're losing 3 electrons. So we start removing electrons from the furthest right. Well, this has got 2, so we can remove both of the 2. And then we can only lose 1 because we only can lose 3. So we can only lose 1, so we still have 3. So the chromium 3+ would be 1s2, 2s2, 2p6, 3s2, 3p6, 3d3. Now this is not how a textbook might explain. This is not how a different video might explain. But if you follow this method, the chances of you ever getting it wrong is, slim to none. I would say none. But again, don't try to learn this material directly from this video. You should have a good understanding of how the configuration works in the first place. And that's very important. So if you have not understood how you do the basic electronic configuration for elements in domain 1 and domain 2, I suggest you watch those 2 videos and then come back to this one. All right, so there's nothing more to add or subtract at this point. This is all you really need. So I'm going to stop this video for a cation at this point because I have done one for each domain. Now anions are slightly different. Now if you remember, metals can only lose, non-metals typically gain. So I'm going to do only one example for the anion because I want you to practice. I don't want to do like 10 different examples. Right, so I'll pause the video here, and we'll pick it up for the next video, which would be electronic configuration of an anion. Right, so stay tuned.